Thanks, Rob. Hi, everyone. I'm Shawn Allen. Like Rob said, I'm a partner and the interaction director at Stamen. And I am here to tell you that, well, a couple of things. First, about Stamen. We love open source software. We love open data. We've championed it in a lot of different forms. And we look for open minds, both in our client world and in the public, to consume and just eat up all of the work that we put out there. And I'm going to be a little bit cavalier and tell you that most of your technology problems and most of our technology problems have already been solved. We have gigantic disks, we have the cloud, we have crazy giant databases and routing network engines, and a lot of the things that I think are core to transportation specifically have been figured out on the technology side. And so what I want to talk about is the design side and design problems. A lot of traditional software ends up in these loops where technology introduces problems and then we pile on more technology onto the problem, and that creates a couple of interesting kind of side effects, one of which we refer to as technical debt, another which we refer to as feature creep, which you've probably all heard in some form or another. But we try to do things differently. And the way we do that is by integrating design and technology and having these two processes inform one another. So good design provides solutions for a lot of the technological problems that we have, and it helps us escape those problem technology loops. And so I'll talk about that a little bit in the context of some of our best practices. One that we like to think about is creating what we call question-making interfaces. And these are interfaces that kind of counter to the traditional practice of creating an interface that attempts to answer every question that you could throw at it. You instead engage in an exploratory process in which you create an interface that prompts new and interesting questions, and then you refine the interface to further answer those questions and get deeper into the problem. So in 2005, we created an application and a website called Cab Spotting. We did this for the San Francisco Exploratorium, which is a kind of children-focused museum, but they were really interested in getting into the kind of digital interactive space. And what Cab Spotting showed at the time was live locations of all of the taxi cabs in San Francisco's yellow cab fleet. And in 2008, this became part of the New York MoMA's permanent collection. And what the visualization showed was in the background, these white lines, the kind of ghosty lines that you're looking at are the paths of taxi cabs over the last 4 hours. And on top of that, we overlaid live locations of 10 random taxi cabs and drew their paths over the last 15 minutes or so. And so the circles show their most recent location, and then the solid lines show cabs that were occupied, and the dashed lines show cabs that were unoccupied. And as soon as we made this, you can probably see it here as well, but we started to notice these weird artifacts, these crazy lines that kind of shoot across the Bay Bridge. And so the dotted line actually shows you the actual path of the Bay Bridge, but then there were all of these lines shooting across them. And so what we asked was, why did these lines, I'll go back to the slide here. So we asked why these lines existed, and when we talked to the yellow cab, we actually figured out that this is a side effect of GPS signals not being sent on the lower span of the Bay Bridge. So the Bay Bridge has kind of upper and lower decks, and the lower deck taxis that were passing through there didn't actually send GPS signals, so they appeared to fly from one end of the bridge to the other. And so we were actually really excited about this because it meant that we were creating a map not just of taxi cab locations, but of GPS idiosyncrasies. And we got really interested in this idea of trying to kind of actually expose those idiosyncrasies and strange aspects of the data. So with the help of a friend of ours named Eddie Elliott, we started plotting lots of the points, and we started to see kind of interesting fuzzy shapes, but we found out that even by just tracing the locations of the entire fleet over a single day, you could get a pretty good picture of the entire road network of San Francisco. And when you zoom in on this, you can see the outlines of individual streets and lanes, highway interchanges, And we actually couldn't help but draw some comparisons between, or some similarities between this and one of our favorite artists of the 19th century, Etienne Jules Mouret, or E.J. Mouret. And he was actually a scientist, inventor, an artist, and a designer, kind of a polymath, who developed tools and techniques for rapid fire photography. He called it chronophotography. And he used these techniques to study the motions of the human body, horses, cats falling from high distances, the subtle mechanics of birds in flight, and all sorts of different topics that couldn't currently be investigated by other means at the time. And his work heavily influenced a gentleman named Edward Muybridge, who around the same time used photographic investigation along with Mouret's technology to prove Mouret's theory that horses actually pick up all 4 of their feet during a trot. And so you can see in the second and third frames there, you can see this is the horse actually lifting up all of its hooves. And until Mouret had created this technology that allowed rapid fire photography, there wasn't a way to actually prove that this was the case. People had to kind of observe it and try to take a photo at exactly the right time. And it wasn't until they were able to do these rapid fire photographs that they could actually learn about how those mechanics worked. So in other words, Muybridge used Mouret's tools and techniques to gather and analyze the data. But then in this case, he actually used design to communicate them. So the original photos that he took were much scratchier and kind of harder to see than that. So he redrew the images in order to communicate them in a clearer fashion. And so like Mouret and Muybridge, we've used time-lapse photography, basically, these data recordings of taxi cab locations, to reveal subtleties in the patterns of human transportation. And so you see these thick lines. These indicate, the routes favored by taxi cab drivers, obviously. There's the little gap in the upper left-hand corner, which is the Broadway tunnel. And then we also figured out, with Yellow Cab's help, that the fuzzy patterns were created by the GPS signals bouncing off of tall buildings in the downtown areas. So we found that really, really interesting. And we, with this data, we're able to make simulations and video that would show, these are pickup and drop-off events, where the circles are sized according to the duration of the trip. And then what we also did was we made the data available to other developers, artists, and researchers free of charge, with the only stipulation being that they couldn't use it for commercial purposes. So this is actually a visualization that our friend Eric Fisher made. You've probably seen a bunch of his work before. And what this showed was taxi occupation status. So occupied taxis are in blue and unoccupied taxis are in red. And the tools in all of these cases, both ours, Eric's, and Eddie Elliott's, were basically whatever we could pick up and find. Open source tools, Python, command line utilities that would convert raster to vector data and back and forth. And so whatever we could scrounge together to translate millions of GPS signals into pixels on the screen, we just picked up and used. And so the process was a little bit more scientific than artistic, kind of like Mouret's, creating and honing tools and figuring out how to automate what would have been really difficult to do by hand. Whereas artists like Hoyo Ryu would use more artistic methods to photograph these airplanes and then kind of cut them out individually and paste them all back together to show the shape of lots of airplanes taking off from a single runway. But cab spotting was not just an art project either. Researchers at UC Berkeley actually used the data to estimate arterial traffic conditions by comparing the known GPS locations of taxis with their model. So cab spotting was in many ways one big question-making interface, both kind of for our artistic endeavors, but also for research endeavors in transportation. So after cab spotting, we kind of got into a groove of adding the word spotting to a lot of our projects, and so we decided to create crime spotting. And this is an interactive view on police crime reports in San Francisco and Oakland. And over the course of its development, we created a bunch of new interactive user interface elements that will allow us to play with this data. So this is the map as it appears more or less today. And when you mouse over, for instance, prostitution reports, you can see that it highlights all of the other reports of that type. And then using the kind of combined legend and selector in the upper right, you can then filter out everything else so that you're seeing just prostitution reports. And in this case, we were noticing, interesting patterns in police reporting. Whether it's prostitution or not, these patterns were really interesting to us because they suggested that Oakland PD was actually performing, specific stings in order to capture or to arrest prostitutes in the Fruitvale District of Oakland. And later, journalists were actually using these same techniques along with the crime spotting data to ask similar questions about the policing techniques, and that was interesting. So some other things that we did with crime spotting data, and this is kind of a detour, but we created some heat maps that show the density of crimes. And I brought this image up to just point out that on this map, what we did was we overlaid the street layer on top of the data and we made it transparent. And people have been doing this with so-called hybrid map providers for a while. But one thing that we try to do with a lot of our data is to actually ensure, especially with maps, that the labels go on top of the data so that the data isn't obscuring the actual points that people use as frames of reference for their maps. So the second principle I want to talk about is flexible design. And when you design something flexibly, it pays off in spades. We do a lot of custom cartography for our projects, and so we bring in OpenStreetMap data, which is basically the Wikipedia equivalent of geographic data. And we use that open data source to create custom maps. And so this was one that we created for CloudMade back in 2009. It's our first custom map style. We called it Fresh. This one is called Pale Dawn, and this one is called Midnight Commander. We actually based it on the look and feel of the maps that were shown in the Bourne trilogy movies, with the idea that if we wanted to show bright data on them, for instance, then we could do that and it wouldn't conflict with the color scheme of the map. So having that flexibility of being able to create a custom map style that doesn't get in the way of your data on top has actually been really useful for a lot of our projects. And so we created lots of other styles, such as Toner. This is a black and white style that actually is suitable for print, but it's also good for overlaying colorful data on top of without the colors conflicting with anything you have on the map. We created a terrain style, which shows you hill shading and uses different fonts. And then we created what is probably our best known map style, watercolor. And this one we kind of went off the deep end with. We attempted to apply kind of Photoshop-like filter effects to map data in order to kind of create a more abstract and kind of whimsical representation of a map. And it looks really convincing in some areas. As you zoom in further, you can see that we've applied actually hand-painted watercolor textures to buildings, streets, water, parks, and some of them line up with unexpectedly beautiful consequences. We also found interesting uses for mapping techniques in non-mapping or seemingly non-mapping projects, such as this one called ArtScope that we did for SF MoMA. And the idea here was that we turned all of the artworks into a big map. And in order to explain how that works, I think I can explain to you basically how Google thinks of the world and Google technology with respect to maps. Google Maps were a major step forward for the web because they turned maps into these interactive objects rather than having to click around through MapQuest. I don't know if you guys remember having to click around and it would refresh the entire page every time you wanted to see something different. But what they decided to do was they split the world up into these little 256 square images. And we took that same approach and did it with artwork. And so by creating this giant canvas and then reconstituting it within the browser, we allowed people to kind of suck up the canvas of images through what my friend Mike likes to call the thin straw of the internet. If you imagine kind of looking through a straw down at the world and then only grabbing the map tiles that correspond to that area, it's a really powerful notion both for interactivity and for loading times for people viewing these websites. So this created a flexible design that SF MoMA can update at will, and they continue to do that every week now. And this has been up and running since 2008. So another principle that I want to talk about is deliberate and sometimes sidelong visualization, the idea being that we make deliberate choices when we choose to create visualizations. And we did this project for Trulia called Hindsight that actually attempts to show the historical development of housing across the lower 48 states. And so this is Discovery Bay, about 60 miles east of San Francisco. And you can see instantly here the order in which all of these houses were made. The color goes from, I think it's blue to purple, or green to blue to purple. And some of these early videos that we made give you, I think, a little bit of a window into that process that allowed us to come up with this idea. So right now what we're viewing is these are properties by year built in San Francisco. And so as we're playing through time, you're seeing the kind of development of the city over time. And this one is of LA. So we can see lots of development over some areas and kind of subtle spreading effects, but a general kind of bubbling up after a certain period of development that's pretty spread. But if we go back to San Francisco, what we were really interested in is, could we actually animate this through a different dimension? And so rather than animating over time, what we decided to do was turn price into the dimension that we are animating through. And so that actually gave us, and here, I didn't set that to loop, but I'll show you this one more time. This shows you a completely different picture of San Francisco that tells you the story of cheap prices in the south and the west, and then exceedingly expensive ones up in Pacific Heights and Noe Valley in the middle of the city. And so this kind of sidelong view, taking data through another dimension and looking at it through this other lens, actually allowed us to think about the data differently and find different ways to show it. So we've done a little bit of that with the Golden Gate National Parks Conservancy, and these are interactive trail renderings, hiking trail renderings that we've done that show you both the elevation view of the trail, but also allow you to kind of get a bird's eye view of elevation changes on the trail so that you can pick one that suits your hiking style. This one was a lot of fun. We did this for NASDAQ. These are visualizations of trading activity over a really short period of time. And in these visualizations, what we did was we decided to color code each trade by stock. And so circles with a similar color or the same color correspond to the same stock. So you can see one stock that's kind of yellow and another that's purple that has these big dots. But we made a deliberate choice also in seeing what it looked like to color them by trader, in which case you see a very different picture. And green is a trading firm called Knight Capital. They say regularity is their business. And throughout these visualizations, you're going to see Knight Capital pop up. So in this one, we're looking at one stock that was heavily traded for a long period of time. And you can see that Knight Capital is responsible for those tradings. This is another example of a really sparse pack of trades that happened over a spread of, the y-axis indicates price. So this was a series of stocks being traded kind of within a certain price range over a very short period of time, probably seconds. And we can see here that when we color these by trader, that this was Goldman Sachs in orange. Another example that shows, another trader. And so as we play this thing forward, I'm just going to show you a series of images here. You can see, lots of crazy trading of a bunch of different stocks here. And then when we switch between coloring by stock and coloring by trader, you notice that this crazy line shooting down toward the right-hand corner was actually, it was two stocks, these are colored by stock, driven down in price by a series of traders, probably dozens. And as we move through time, we can see the bell going off at 9 a.m. here and tons of large stock trades happening. Knight Capital is responsible for many of those. And then we keep moving through time, and we can see another little blip here at 9:05. And this is a rapid-fire series of trades on a multitude of stocks in just seconds. And by making this deliberate choice to visualize both trader and stock, we're able to look at this data through different lenses and ask new and interesting questions of it. So we had another opportunity to do a kind of sidelong view of of data when we participated in the 01 Biennial at the Tech Museum in San Jose. And the project, or the biennial subtitle was City from the Valley. And the idea was, we actually submitted a proposal to visually engage with the flows of capital between San Francisco and the Valley. But what we realized pretty early on was that we didn't know very much about the Valley. We operate on a kind of city-specific basis. But what we did know about was all of these corporate shuttles that drive around San Francisco. Are you guys at all familiar with this phenomenon? In San Francisco, we're actually inundated with lots of private corporate shuttles that take workers for Facebook, Google, Yahoo, and the big tech firms directly from San Francisco neighborhoods to their campuses in the Valley. And so we decided to kind of engage with that data and see what we could learn about it by kind of collecting our own information. But we hit a pretty big snag initially, which is that none of that data was actually available from any of the companies. Google, Facebook, Yahoo, none of them wanted to share their bus schedules with us. So we went out and actually were able to find a bunch of it. SFMTA had done a study previously that we cribbed some data from. But what we found, actually, the easiest first step was to go on Foursquare and search for shuttle stop. And what we arrived on was a list of dozens, I think maybe even 100 shuttle stops that had turned into Foursquare check-in locations because Facebook, Google, and Yahoo employees had decided to kind of make it their thing to check in at their shuttle stop. So we found lots of other shuttle stop locations, potential shuttle stop locations this way, but then we also hired an army of bike messengers and other willing accomplices to help observe these buses throughout the streets of San Francisco. And we created lots of maps like this with an application that we call Field Papers that allows you to print out a map, draw on it, and then you can trace the data back on your computer by scanning or photographing the image. And what we arrived on was a kind of fuzzy subway-style map of these private shuttle networks. And this drew a lot of media attention, mostly because San Francisco is undergoing a pretty big shift in demographics, and people are talking about gentrification, and somehow this map became kind of a touch point for that conversation. And while that wasn't necessarily the kind of political consequence that we had hoped to when we made the map, it was an interesting side effect, and we were happy to be kind of a part of that conversation. So speaking of transit and time, I wanted to take a little bit of a detour to show you guys a couple of examples of ways that design thinking can improve a typical experience, such as the lowly transit timetable. So I'm going to go all the way back to our friend Etienne Jules Marais in the 19th century, who also produced this graphic, which is a really celebrated visualization of the train schedules in and around Paris. And so one of the most celebrated aspects and most interesting aspects of this chart is that on the y-axis, the stations are actually spaced out by their geographic distance from one another. And what that produces is the effect that the slope of each train's line across it actually tells you its speed in any given moment, time being consistent across the x-axis. And so, this one kind of seemingly subtle modification to, a typical chart that might just space them all out evenly on the y-axis actually produces a whole new aspect of data that people can intuit automatically just by looking at the chart. And our friend Eric Fisher made some very similar charts of BART schedules versus actual timing on the right. You can see it's a little bit more chaotic than they expect. These are not spaced out according to geographic distance on the y-axis. But Mike Bostock, who's the creator of a very well-known JavaScript visualization library called D3, recreated actually Murray's graph using Caltrain schedules. And you can see here that in some cases the baby bullet trains, which are the red lines, overtake some of the slower trains in certain areas. Our friend Brandon Martin Anderson has done some really cool traffic, or rather transit accessibility visualizations with open source software called Graph Server. This is in Seattle, I believe, and this is in the Bay Area with the red lines corresponding to BART tracks. So these are all static renderings that do a much better job of communicating transit and time better than the traditional timetables. And we talk about intuitive interfaces with instant feedback, and so I can show you some things that are actually interactive. And so we're big fans of an idea called direct manipulation, where what you're actually moving on the screen corresponds to the data. And we implemented this using transit time data from My Society, which is a political advocacy group in the UK, to create these London travel time maps. And the idea was you use the slider to manipulate the kind of threshold of travel time that you're willing to accept from a particular area. So the origin here is the Olympic Stadium. And then what we did was we added another dimension to the data, which is the median housing price. And so you'll see there's a kind of minimum and maximum on that slider that allows you to kind of move through that data in 1 and 2 dimensions, both the travel time and the housing price. And earlier this year, we designed and built this visualization of seagrass density for the Chesapeake Bay Conservancy. And we took a much more low-tech approach to this than we did with the travel time maps. So there's a slider on the bottom that takes you through time and shows you seagrass density changing throughout the bay. And you can select research areas, and you can see charts that show you temperature, salinity, turbidity. And then we use very low-tech techniques, such as just plain old HTML tables with visualization scales that allow us to show you temperature fluctuations over time, both by year and by month. And I think that a lot of these techniques are applicable in your field as well. So perhaps even more relevant for you guys is a project that we did with the Metropolitan Transportation Commission in the Bay Area. And this is part of their One Bay Area initiative, showing the kind of connections, the oft-sought connection of travel time and housing. And so what we're showing in blue on the right is all of the areas that are accessible from the Stamen office within 30 minutes. So the slider allows you to change that threshold of time. And you can also change travel modes on the top left, and you can change time of day. And when we go to evening time, you can see that transit accessibility is affected. We go from morning to evening, and so there's less transit at night. That much should be obvious. And when you're on a bike, a lot more of the city is available to you within 30 minutes, ignoring that there are giant hills in the middle of that. So when we start moving around the housing price slider, though, so I'll go from previous slide to this slide, you can see that we've gone from 2 million plus down to 500,000. So if you can't afford to buy a house for less than $500,000, there aren't many places that you can live that put you within a 30-minute bike ride of the Stamen office. And so we found this really interesting, and it's one of the other things about this map that was really important was that all of these views are shareable. And I'll touch on this in a second, but the idea here is that every single one of these views that I've shown in these slides creates a unique URL that somebody can copy and paste into an email, send to a tweet, that other people can click on and they'll see the exact same thing. And we like to talk about this as sharing equals caring. And the idea being that both concise and meaningful URLs and ones that actually save and restore the state allow people to more easily share the thing that they're looking at with other people. And so I've seen a lot of really heavy UIs, especially for transportation and traffic analysis, that don't change the URL at all. And so how would you share your view of that? You would copy the URL, send it to somebody, and then try to list out all of the steps that you took to arrive at that view. There's a much better way to do it. Last but not least, there's a principle that I like to talk of as beautiful is useful. In the early days of visualization, on the web at least, when we first started around 2001, the phrase beautiful but useless was thrown around a lot to describe things that were beautiful, objectively beautiful, but subjectively useless. And I really fought to try to counter this notion, because I believe that beauty is a necessity for visualization project success, particularly Stamen's. So this is a good example, a map that I made by combining 3 different data sets. There's tree locations, urban tree locations, crime from our crime spotting data set, and taxi cab locations from cab spotting. And this was interesting because I was mostly trying technology, and trying to figure out a way to intersect 3 different data sets, but ended up with a beautiful design object. And oftentimes maps like these are not the final product. So while this was a weekend experiment that I threw together in a couple of hours, it actually ended up being picked up by the Venice Biennale in the US Pavilion, and turned into an example of an urban intervention. And like many of our maps, it started an interesting conversation. How can you throw different data sets together visually in order to help people find patterns and recognize them? And so Eric, our founder, my partner, likes to talk about this as the intersection of analysis and spectacle. And we've really been at the forefront of web-based visualizations and mapping for over a decade, and found really that spectacle is what draws people to your work. You need a certain degree of sheen, of design, of beauty to really draw people into the work and get them interested. And so it's really about that interplay of design and technology, and I want to underscore this point because I think that design is really important in your field. It's a fundamental component of our work, and the technology alone cannot solve all of your problems. You guys need good designers in all of your applications. Like fast cars, great laptops, and even really efficient transportation networks, they all require good designers. And robust technology, obviously, but the design and the technology need to work together. So that's it. Thank you. Okay.
I think we have time for a few questions.
Yeah, questions? Yes?
Some of this almost seems like geospatial intelligence tradecraft. You're trying to find ways to get information about things that people want to share with you.
The Silicon Valley bus map certainly was, yeah. And we employed a lot of techniques that, that we wouldn't have even thought to, we never would have imagined having to hire bike messengers to follow buses around. But our kind of thirst for that data really prompted us to get out of our comfort zone.
So how do you see this integrating with concepts like volunteer geographic information or geodesign?
Sure. So field papers, and I probably should have included it in my presentation, but check out fieldpapers.org. It was actually a project that we worked on with USAID. The idea was that you create a map somewhere online on the website, and you print it out, and you can distribute as many of those maps, and you can create multi-page atlases to people on the ground who don't necessarily have any technical expertise, and they can draw and write on the map. And then what we've done is put little watermarks in the corners of the map that allow you to, once you've scanned it or photographed it, kind of bring that image back onto the kind of rubber sheet of the earth, so that you can trace the data in geographic space.
So basically a way to easily transform the analog back to digital.
Exactly. Yeah, and we found it, we actually started it to more easily facilitate the modification of OpenStreetMap data, because it was lacking, other interfaces other than digital, where people were having to kind of trace aerial imagery. But we found that kind of the analog route was useful for a lot of people, especially for distributing work among folks who don't want to learn some new online interface. But tradecraft is definitely a word that I would use to describe a lot of our work.
Do you hire any former spooks?
We haven't yet. Oh, yeah.
Hi, great presentation, really beautiful. I'm Chris from SFMTA. I have a question for you about sort of engagement with government and data.
Yeah.
You've really shown a great way to display data in new ways, and also the part about beautiful and useful, engaging people with the data. What are your thoughts on basically what you showed here today in terms of improving public engagement, government transparency?
Well, we actually, we worked directly with the city of San Francisco when they started their open data initiative in 2008. And what I didn't talk about with crime spotting, because there wasn't really enough time, but Oakland crime spotting was actually a kind of more subversive attempt, kind of like the tradecraft, to free a source of data that was not open in Oakland. And when San Francisco came around and introduced their open data initiative, they actually came to us and said, hey, we saw that you were able to make this map of Oakland data, and we heard you had a really hard time getting the data. We've got San Francisco PD's data right here. Do you want to make a site for us? And because we had gone through all of that hard work of creating, the framework for the site and even, the hard work of figuring out how to get data into the form that it's presentable, we were able to turn around San Francisco crime spotting in the matter of weeks. And so, yeah, I mean, we've been engaging with open data for a long time because we feel like our processes and our views on it are unique and useful to the other communities. And we've, in some cases influenced the development of like the San Francisco 311 API. We helped design that for the city. Yeah.
Have you dealt with data quality with individual data, or that's a particular problem with open data sometimes?
Definitely. Yeah, well, even private data. When we first engage with clients, we have them send us as much data as they could bear to. And that initial process of discovery is one of the hardest parts, where we try to figure out, given the client has told us what the data model looks like, but figuring out whether there's, noise or kind of digital dirt in that data, we've definitely had to deal with it. And often our approach is just to say, okay, we're going to only take the stuff that meets this criteria because that's the only stuff worth visualizing. But there's there's almost a whole discipline of cleaning and working with dirty or noisy data that we employ on a fairly regular basis. But at some point you have to start making things too.
There's a whole body of work that's in terms of visualization of quantitative information you get from testing.
Yep.
Have you used any of his material or ideas or concepts?
Well, I think he's the one who really, who championed a lot of Murray's work. And that transit schedule that I showed was actually featured in I think, the qualitative display of information. And yeah, we reference a lot of his principles. The only issue is that a lot of them don't apply to interactive work. So things that are dynamic, that are changing all the time, either in response to user input or a live feed, you kind of have to throw the book out the window for a lot of that work because it doesn't apply. It's easy to say that there is one ideal representation for a static data set, but when the data is changing all the time, you have to take a slightly different tack. Yeah.
Follow up to his data quality question. Sometimes you see a scenario where large amounts of subjective, messy data are actually a better model of reality than small amounts of objective, carefully controlled data.
Yeah.
Which is counterintuitive in, even like, I guess, some story from Harvard Business Journal about how before scientific mapping, the hearsay information about the interior of the African continent was more accurate than all the scientific information that has been collected on the coast. So that's very counterintuitive to engineers.
Yeah.
We think if it's subjective, it's not true.
Right.
But we're talking about big data. What happens if the richness of big data overcomes its messiness to the point where it's more accurate?
Right. Yeah. And I think that we've seen hints of this in some of the work that we do. We for what it's worth, we tend not to deal with what I think is commonly referred to as big data. We're actually big fans of little data. Because we're a small firm. We're 12, 13 people, and we don't necessarily have the infrastructure to deal with terabytes of streaming data. But we're also looking for quick, easy wins to visualize our clients' data and help them communicate their information to people. But I think to the point of there is a structure that becomes visible when you view enough subjective or messy data. And we've certainly seen that. I mean, There's a visualization that Bill is showing at our booth out there that's a video of Facebook shares for popular photos. Take a look at that. I mean, the data itself is well structured, but it comes from messy interactions, people sharing, this one photo on a social network with, select friends of theirs. And I think that there's something to what you're saying, this idea that, structure kind of reveals itself once you have enough data to look at. And we're kind of just reaching the tip of the iceberg with that stuff, like as a society, as a culture. Yeah.
With your crime spotting data in Oakland,
Mm-hmm.
did the data prove out that crime went down when there was a Raiders game and that they were all watching the game?
Yeah, it's we didn't really attempt any of those analyses, and what we had hoped was that by creating this really simple website and making the data available to other people, that we would inspire them to do that. But it was early. It was 2007, 2006 when we first put the site out, and I think if we were to re-release Crime Spotting today, we probably would see things like that happen, because there are many more people who are just interested in data, who have tools at the ready, things like D3 and these visualization frameworks that they can just pull off a shelf, throw data at, and see the results and share them really easily on the web. I think I'm kind of looking at Bill saying, well, we might redo Crime Spotting at some point, but we have paying clients in the meantime. Yeah.
In traffic signal timing progression analysis, they use space-time diagrams. They're similar to the train schedule. Have you looked at those in any of your projects, or are you aware of that?
We're actually looking at them with Iteris right now. I think some interesting work will come out of that relationship. So yeah, we're thinking about it for sure. There was another question over here too. Yeah.
Yeah, you said you don't like big streaming data sets, rings of data, but have you done any stuff with RSS feeds or any other real-time?
Certainly, yeah, and I guess I'll take back the thing about streaming data, because one of the big projects that we did early on was a site called Dig Labs. Do you remember Dig? Does anyone remember Dig? It used to be one of the most visited websites on the web, and it was a place for people to share links, and they could, you would post a link somewhere, and then other people would dig it to say they like it, and people could comment on them and so on and so forth. But what we created were, at the time, some of the first visualizations of live social network activity on Dig that were, they were charts that changed in near real time. They were, kind of swirling images of nodes interacting with one another. They were arcs connecting around a circle. So we love streaming data, and actually a lot of advances have been made since that time, when you just had to continuously poll a server, rather than now we have actual WebSocket streams and the technology to support pushing lots of data through even just a web browser. So again, it's early days for a lot of this technology, and if we find a client who has an interesting application for streaming data, we're totally down to see what we can do with it.
You see real-time traffic now, related to Google, whatever.
Sure.
So I was wondering if you did abstractions of that kind of government type of data.
I think that the dig data is similar conceptually. It's an abstraction of social networking data, but I could imagine feeding traffic data through those visualizations and seeing something completely different. We have a kind of, the abstraction is kind of where we have a lot of fun. It's taking a data set and looking at it through a completely different and entirely aesthetic visual lens, in order to arrive at something that was unexpected and hopefully interesting.
Or one could say how to lie with maps.
You could say that, yeah. I put this. It's an old naval poster in the background of this last slide. Across the top, it says "Maps are not true for all purposes." And yeah, I mean, I actually, as a teacher of visualization, I sometimes I have to criticize, my peers' work or my colleagues' work and say, hey guys, you can't put lots of overlapping circles on the map together like that. And that's just one example. But yeah, there are lots of ways to lie with data and with maps. We're looking for interesting interpretations that I think pose more interesting questions and allow people to kind of grapple with the data in a different way.
How do you, with your commitment to creativity and sort of special corporate values, how do you resolve that with the need for paying clients? And are you now in a position to sort of select who you want?
Well, we do all of our biz dev through referrals, and so we treat business as a kind of incoming stream and pick and choose our clients based on our values. But based on the work that we put out there, we don't tend to get lots of requests for the type of work that we would turn down. And we actually see our commitment to open source. We release a lot of open source code and open data and openness in general as a way to actually attract clients who have similar values. So by expressing a lot of those values publicly, and I think we've been successful in attracting people who share them. Yeah, thanks.